On our second page, we are going to solve some more of these equations, and the first one is 3a is equal to negative 18. Now we need to solve for a, we need to find what a is, and a is being multiplied by 3 on the left hand side. So to undo multiply by 3, we need to divide both sides by 3. So we take our 3a and divide it by 3, and we do exactly the same thing to negative 18. We divide it by 3. The 3's will cancel out on the left hand side, so we're left with a, and on the right hand side we've got a is equal to negative 6. So that's the solution for that one. Of course, you can check by substituting a is equal to negative 6 back into the original equation. Let's move on and have a look at the next one, which is a quarter times x is equal to 2.5. So a quarter times x, well, that's the same as x divided by 4. Okay, x, a quarter of x, it means x divided by 4. And we know that that's equal to 2.5. So we do exactly the same thing to both sides of this equation. We want to get rid of the 4 in the denominator, so we will multiply both sides by 4. So we've undone divide by 4 by multiplying both sides by 4, and on the left hand side the 4's will cancel out because you can think of 4 as 4 over 1. So we're left with x on the left hand side, and 2.5 times 4 is equal to 10. Our next one is one that we had in the original, on the first page I think of this week. It's 2x plus 10 is equal to 56. Now what are we doing to x? We're multiplying it by 2, and then we're adding 10 to it, and all of that is equal to 56. Now remember that when we undo equations, so actually what I was going to say was that we're actually doing a couple of things to x, multiplying it by 2 and adding 10 to 2x. So we need to think about the order in which we undo, remembering that it is in the reverse order of operations. So that means we need to undo any addition and subtraction first. So with this one I'd undo the addition, and the addition is plus 10, and we're going to undo it by subtracting 10 from both sides. That should be subtract, not divide. So let's do that to both sides. And of course on the left hand side, 10 subtract 10 is 0. We've got 2x is equal to 46. 56 take away 10 is 46. Now we can undo multiplied by 2 by dividing both sides by 2, and that then should solve for x. And of course the 2's will cancel out there on the left hand side, and we have x is equal to 56 divided by 2, which I think is 28, isn't it? 52 goes into 5 twice, and 1 left over, 2 goes into 16 8 times. Next one, 2x minus 4 is equal to negative 14. Remembering that we undo any addition and subtraction first, so we'll have to undo subtract 4 by adding 4 to both sides. And so we're going to do exactly the same thing to both sides. There it is, we're adding 4 to both sides of the equation. Minus 4 plus 4 is 0. So we have 2x is equal to negative 14 plus 4 2x is equal to negative 10, and now we need to undo multiply by 2 by dividing both sides by 2, and that will cancel out, and we'll have x is equal to negative 5. Again, you can check by substituting, and I think I have that in the work solutions for all of these. Now if you take your x is equal to negative 5 and substitute that one back into the original equation, let's just get a different colour here. So if we look at the left hand side, 2 times negative 5 minus 4, that's equal to negative 10 minus 4, which is equal to negative 14. So yep, that answer must be correct. So that was the check. Bit of a bright colour, let's go back to something a little easier on the eyes. Now these ones are a little more difficult. With these ones we've got what we call algebraic fractions. So it's an algebraic expression, x plus 7, and that's divided by 2, so hence it's an algebraic fraction, and that's equal to negative 4. So what do we undo first? Well, we've said that we undo addition and subtraction first before we undo any multiplication and division, but we've got to be a little more careful with this one, because if you look at the expression in the numerator, it's x plus 7, and remember there's an implied bracket around an expression that is in a numerator or a denominator. So the very first thing we need to do in this one is leave the bracket but undo the divide by 2 on the left hand side by multiplying both sides by 2. So we'll take 2 and multiply it by x plus 7 all over 2, and then it'll be negative 4 multiplied by 2. So we've done exactly the same thing to both sides. We've multiplied both sides by 2, and on the left hand side they'll cancel out. So we're left with x plus 7, and of course now we can remove the bracket. X plus 7 is equal to negative 8. Now it's just a matter of solving for x by subtracting 7 from both sides. So x plus 7, we're only doing one thing to x, we're adding 7 to it on the left hand side, so let's subtract 7 from both sides. And of course the 7's disappear on the left hand side, so we're left with x is equal to negative 15 on the right hand side. And it's easy enough to substitute that back in. I'll let you have a go at that one. The next one is a slightly different sort of algebraic fraction. You'll see here the algebraic fraction is just y over 3. So there is no implied bracket around the whole expression here because we've only got one term in the numerator. So in this one, let's just get that. We need to do exactly what we did previously, undo any additions and subtractions first. So we're subtracting 10 on the left hand side, so add 10 to both sides. And of course the 10s will disappear there. So we've got y divided by 3 is equal to 22. We need to solve for y. It's being divided by 3. So multiply both sides by 3, and this one gives us a rather large answer. These will cancel out, and we've got y is equal to 66. And again, substituting in y is equal to 66 into the original left hand side, and you will find then that both sides of the equation will give you the same answer of 12. Now, slightly difficult one, more difficult one, x squared. If x squared is equal to 25, that means if we take a number and multiply it by itself, it gives us 25. The squared is one of those exponents, so how do we undo squared. Well, what we need to do there is take the square root of both sides. And you can do this on your calculator. There is no other way that we show you how to do it manually. The square root of x squared is just x. We're looking for a number which multiplied by itself will give us 25, and that answer is then going to be 5, because 5 times 5 is equal to 25. But if you stop and think about it a little bit, there is another answer as well, which your calculator may or may not give you. I don't think they do actually, and that answer is it could also be negative 5, because if you check that, do a quick check on negative 5 multiplied by negative 5, negative multiplied by a positive, a negative multiplied by a negative is positive, and 5 times 5 is 25, so there are a couple of answers for that one. Okay, that's the end of that page, so I'll just stop that recording and go to the next page.